Hey everybody.
Hello, everyone. We'll get started and I'll start with introductions. So we would like to keep, I think this conversation is going to go over an hour, depending on how deep we go into the process. So quick introductions. I'll explain context for why this conversation is happening. And then Moises, you can introduce yourself. So hi, I'm Poi. I'm co-founder of AIxDesign. We're a nonprofit community interested in making AI work for the rest of us. We do that by gathering people like you to deconstruct, challenge mainstream narratives of AI, reconstruct new narratives that work for us. That can be 100 things, whatever was working for us at the time, and then make them real. We make them real in a few ways, and this conversation is supporting this thing that we think is important. And we haven't done this structurally, which is recording the process, documenting the process of how folks that we know in our community, who we work with, who we respect and admire, how they're making AI systems that do something that commercial AI hasn't been able to do yet. This is our first conversation, recorded conversation. We've had conversations in the past, just as an FYI, Moises and I have. But this is the first in this format. This is the first in this tool stack. And so this is the context in which you're joining us. There's also two, like I mentioned before, there's two projects that we're going to use insights from this to inform. One of which, Nitya, is a researcher, and together we're on this project with IMI based in the Netherlands, looking at pro artist AI in music making. So what are some like equitable ways that music makers can use AI products throughout their production pipeline? How might they use it? And then how are indie AI makers making AI tools with like pro artist features inside of that? So this conversation will inform that research project. And then there's another project, which is this On Slow AI conversation series, which is the thing that you guys might have RSVP'd to. And the premise of this is that we want to have these deep dive conversations, which we find we're having in private, which are like geeky conversations about the nitty gritty details about data. Where are you getting this data? Are you using new data? Are you using existing data? What file types are you using? How did you get it? Was it on a USB? Did you scrape it from somewhere? What file type did you save it as? How much did you get? Technical maker questions. We want to like talk about models. Which ones did you try? Why did you try them? Did those fail? Did you go get new ones? Where did you get those from? How are you finding out about these models? What is like the hosting infrastructure? Some folks are doing things locally. Others have their own servers. Others are using the cloud storage stacks. How are you using it? What is your like maintenance compute cost for ongoing stuff? Is there any? We want to have all of these conversations about like what it actually takes to build the thing. And so this is the first one. We're testing the format. We're testing the tech stack. So helpful feedback from you guys is like, is this format working? Is this tech stack working? And like, what else would you like to hear? I think one of the other questions that we have is a philosophical one, which is like, was it at all worth it? So many folks who are building these new systems think that it's possible or other outcomes possible. It's a lot of work to build this stuff. When it all is said and done, was it worth the stress and to figure it all out? That's where we'd like to go in this conversation.
Yeah. I'll also probably jump in with some questions about like how the collaborative process was for you and just like maybe some questions about like your expectations and what you thought would happen and what actually happened and things like that. So yeah.
Yeah, Nitya is going to hold me accountable for asking case study related questions to the music project. I'm going to hold myself accountable, and also Nadia's here in ghost mode to hold us accountable to the larger slow AI conversations. And Moises, you're just going to go off and freestyle. And we might course correct or prompt you to answer things. Okay, that's the introduction. Welcome, everyone. Moises, do you want to introduce yourself and get us started?
Yeah, sure. Thank you so much, Ploy and Nitya, for being in the conversation. I've talked about this work, Semilla AI, that I'm building for some years. It's a project that started, I think, around 20, let's see exact, 2021, even 2020. So it's I see it as ongoing research. It's not like a finalized product, let's say, that I have released, even though there's been a release already. And yeah, so I'm going to talk about that. My background is, yeah, my name is Moises Horta, also known artist name Exorcismos. Cool. So this is just very, if we're going to freestyle, let's freestyle. So I was just going off looking for some very early prototypes of Semilla. Like right now, this is from 2021, which is pre ChatGPT, pre Claude Code, pre all these large language models, and pre all this big industry that developed over the past 5 years. So I think I would like to frame the conversation also in that regard, like to see how everything has evolved from my perspective in building in the space to now. But yeah, the presentation is, yeah, I've titled it An Artist's Approach to Neural Audio Synthesis for Music and Audio, which is a wider study into the topic of AI systems, music technology, labor collaboration between humans and AI systems, as well as a question of data sovereignty, like contextualized data. Yeah, so I'll just start with this. It's gonna get a little bit technical. I'm also gonna talk about the latest paper that I'm writing about Semilla. So this is where I'm kind of like putting everything together. All right, cool. So yeah, my background is in music, sound. I'm a sound artist, electronic musician. I'm originally from Tijuana, Mexico, and I've been working in the fields of electronic music for about 15 years, and also more specifically in the field of computer music. And my background is an electronic musician, and one of my interests is how technologies in general, more specific computing technologies and music technologies, are systems that are embedded with a certain history and a certain politics and a certain culture. And I'm interested how these topics are intertwined with emerging technologies and how we think about these emerging technologies. The practice that I do as an artist is attempting to create a sort of tension between juxtapositions that you would think are not compatible, such as tradition and what you would call futurism. Even though I'm not so, futurism itself has a very specific history, so I'm more, let's say, thinking about the time that is not the present, thinking about a forward in time, not to necessarily link it to the word of futurism, no, so more about thinking about a time that is yet to become. So within these juxtapositions, I work with music, I work with technology, and this under these topics, I also have a music project which is called Hexorcismos, which puts these different ideas together about music and technology and composition and labor and cultural provenance of technology and data to create music. So basically, that's kind of my big interest into going to all of these technologies. No, like I'm asking myself, how can we harness, more specifically, talking about AI? How I'm very interested in how can we harness the malleability of working with data of generative neural systems or generative AI systems to explore and compose like with sonic neural networks. I call it like synthesis networks, so networks that produce sound, not necessarily like yeah, like text based. I'm very specifically going to talk about music and sound for this talk. How can I engage with them in ways that transcends more imitation of their training data? And also, I'm very interested also on the cultural provenance of the data, but also rather than just being interested in the idea of imitating the data that we're training on, how can I create systems that can go beyond mere imitation of their training data, right? So when I engage with certain data sets that come from specific cultures, musical cultures, I'm more interested not a perfect reproducibility of those musics, or those sounds. I'm more interested in these and what these technologies enable for the creation of non-imitation training data. Of course, there is a provenance in the training data, mainly of how the sounds are going to be represented or which sounds are going to be represented within the training of models. But I'm interested in you could say, the glitches of these sorts of systems. So,
I have a question.
yeah, sure.
I have a question about why you're not interested. Is there a reason why you're not interested in imitation of sound? Or is there like
I'm interested in, I guess it's a bit of a philosophical reason. I'm interested in the topic of non-reproducibility as more like non-mimicry as a way to understand the system, like a AI system that can go beyond, yeah, just basically spewing out the same thing that you would put into it. No, so I'm interested in the idea of the AI learning the representation of the real data. Of course, it needs to learn a representation of certain sounds, of certain ideas. But I'm more interested in this idea of, I mean, not necessarily general, like some people would call it generalization or like the underfitting. I'm more interested in the underfitting of the data, as you would call it in the very specific AI developer terms. So when you train a model, there's different behaviors of the learning patterns that they start emerging when you go through the training process, right? So one of the things in like the broader AI industry is that the systems are trying to reach a certain generalization, which this generalization, in my opinion, as an artist and as a musician, is very linked to the idea of universality, right? To create a system that is universal, right? That can encapsulate all different modes of thinking, all different modes of languages, culture, so on and so forth, and that can generalize in the behavior that it can have. No, so this is what people call in Silicon Valley like general intelligence. That it's a very finicky term. It's a very loaded term. It's a very it's a bit of a speculative term. It's not really something that exists in the world, but it's like this idea to reach towards a system that can achieve like some kind of universality for all humans. No, and I see this as something very it comes from a very specific tradition of mainly talking about Western thought, right? To think that Western thought or Western technologies can reach a certain universality over the whole world, basically, you know. So I'm more interested in how the systems, using these same systems, how they underfit to the data. So underfitting means that it has learned a bit of the patterns, but it's just close enough to, let's say, to chaos or to noise that it can produce something that points towards the patterns of the data, but it also still has this chaotic nature to it. That I would say is where like humans and animals and like we have a lot of entropy, and basically AI systems are trying to create a distribution over this entropy, which you can visualize it as a Gaussian curve, right? So you're trying to fit the data into this universality of like that this curve ideally is going to fit over all thought, no, or human thought. So I go towards kind of the opposite. So I'm trying to not create a curve. I'm trying to maybe make like the opposite of a curve. It could be where I'm more interested in these other outlier parts of the distribution that are not that. Of course, like there is some fitting of the data, but I'm more interested in the outliers essentially that emerge from training systems that have originally been designed in certain cultural contexts. Um, and my work is a bit like an experimentalist, no? So I'm trying to build systems and I'm trying to test them in the real world in music. So this is a bit the background here. So I'm gonna share my screen again, and I'm gonna very briefly talk about neural audio synthesis. Okay, yeah, cool. So very quickly, I'm gonna do a speed run through what this all means in more material terms, like so within generative artificial intelligence, there is a branch that focuses on generative models for sound synthesis that are called neural audio synthesizers. No? So these are systems that take raw audio data. So like you can think about MP3s, waveforms, other different audio files, and try to create a representation or a model that can best reconstruct. Essentially, that's the target of these different models in architecture. They're trying to reconstruct perfectly the data that you put in. And the idea of a generalist system is that it can also reconstruct data that it never saw during its training, right? So neural audio synthesizers are, you can think about them as an encoder, decoder architecture. So something like a codec that encodes information into a more compressed and lower information representation that can then be brought back into real audio. And within this field, there is a concept called the latent space. And within this, I'm going more specifically into Semilla, I'm using this architecture called real-time audio variational autoencoder, which is a open source implementation of VAE, which essentially a VAE kind of looks like this, no? So on this left side, you can think about your data coming into the model, and then all these different connections are the weights of the model that get tuned during the training process in order to better reconstruct the data. So on the right-hand side, you have a reconstruction of your data, and you have this latent bottleneck or the latent space in the middle, which is this dimensionality reduction. Also, let's say that your data is a very high dimensionality data points, such as audio. So I'm getting extremely technical now. Please bear with me. I'm going to go more into the artistic side in a bit, but just to get a very material understanding of what's actually going on here. So essentially, we're talking about audio files that you essentially learn through slices of them. So you can think about like 1.5 seconds or 2 second slices of this whole data set. And then the task of the network is to compress these high dimensional inputs, sound inputs, into this very low dimensional representation that gets represented as essentially two numbers. And then from these two numbers, it can learn how to then recreate it back into hopefully super high quality audio that you can then reconstruct from the data. So essentially, you can think about these models as a sort of like a very basic artificial neural network. That the idea of this latent space is to create a representation similar, metaphorically similar, as how a biological being or a human would understand of learning how to make a certain sound, for example. So the sound itself. So when you listen to music, or when we listen to music, the sounds, of course, are coming into our nervous system through our ears, getting transformed into electricity and triggering a lot of different patterns in our brains, right? So it's generating different brain waves and different responses in response to that music. But then when we try to make that music, let's say we try to make a certain genre of music that we've listened to before, we're not actually sampling directly from that sound, from that essential sensory input that we had. So this electricity that we had when we heard those sounds, right? We're trying to recreate it based on a representation that is in our brains. And essentially, you can think about this same metaphor for a network where the latent space is, let's say, that, that representation in your mind of how you would reconstruct or how you would make again this sound. No, so essentially this is a operationalized mathematical metaphor of this kind of process. No, that you have an input takes in sound, and then this output you can reconstruct that sound. So in this case, this is kind of your ears, and this would be your mouth, on the other side. So you can generate a sound in a way. So this is just like a very abstracted version of an output system for sound. So within this representation, you have this thing called the latent space. So this latent space is, if you remember, is this middle part. So is this mind, let's say, this mind memories of the AI. This essentially gets represented where similar sounds or perceptually similar sounds would get clustered into similar regions. You can think about it as a 3D map. So let's say that these dots over here represent bass sounds or very low sounds. And then this cluster on the right side could be very high pitched sounds. So between the low pitched sounds and these high pitched sounds, you can create trajectories in this latent space And then you would get that morphing, so no, that transformation between this representation in the latent space to this other representation in the latent space, right? So it's, let's say that it's like traveling within your memories of how certain things can get reconstructed. So you essentially create trajectories, and this is how you essentially engage with these sorts of systems, because these sorts of systems are made with still a higher dimensionality. We're talking not only 3D maps, but rather like 64 dimensions or higher dimensions. One way to explore these systems is to feed random variables. So basically, you can think about this random variable as a coordinate point within this 3D space. So this is like a random point that you sample after you train a model. And then this random point, let's say that you get sent on this side, and then you sample another random point on some other, and it gives you some other coordinates. You can do mathematical techniques such as nonlinear interpolation, or basically traveling between certain points to create sounds that are representative of what would be in the middle of those 2 points. And essentially, you can kind of see here in a visual representation how the latent space gets represented in perceptually similar directions, right? So on this side, you can see that the number ones are mostly in this cluster, and then on this side, you have number 7, and so on and so forth. So these are numbers, but you can think about this as sounds as well, no? So this is just the general structure that it would create for these types of models. So something that got me into like very interested in understanding these type of models were from 2015. So that was the first time I heard neural audio synthesizers produce music. So these were one of the first systems that were generating sound in this way by predicting the next waveform and having this internal representation of the sound. So you can think about them as sounds that resemble, so they're trying to mimic the original sounds, but when just generating from going into different random points in this latent space representation, they produce very uncanny sounds that sound like the real original sound, but have these other properties to them because they're essentially you're recreating sounds that are non-existent. Their representations are existing within the latent space, but you're recreating sounds that are not really in the data set, right? Just by going within this latent space representation. So this is why I'm mostly interested in the sound representation. So I'm mostly interested in the raw audio representation, which is here on the right side, because to me, the raw audio representation is more akin or more direct to our ears. So our perceptual representation of sound, right? So basically, you have a waveform, you have energy, and within this time continuum, you have a lot of different timbres and sounds and rhythms or what have you. Rather than in MIDI representation, this is already encoded with a specific symbol. So these are just symbols that can potentially produce sound. I think it got disconnected again for some reason. So this basically I chose the latter. I chose the raw audio representation because I feel there is less, let's say, cultural bias into just hearing, like listening to a sound, than to having, let's say, notation music, which is just already embedded in a system of how certain music can be represented with certain symbols and within certain framework of understanding, especially in electronic music, right? Where you're working with the piano roll, and the piano roll embeds a very specific Western distribution of sound and so on. So I feel like raw audio can have a bit freer representation from these kind of specific cultural biases. So yeah, any questions so far? I promise this is the last part that's super technical.
I think this is helpful. This description is really helpful in understanding how the technical capabilities of this material, of like AI modeling, how your understanding of this stuff has informed what maybe comes next. These like different elements that you're pulling out, for me, sounds like starter materials. These are like the constraints that you're working with as you move forward into talking about Semilla. We can show questions on stream. Is the input data a waveform? I mean the input for training.
Yeah, exactly. So the input data is for the model that I'm using for Semilla is 48 kilohertz sample rate at 60 bits depth. So it's essentially a waveform representation. So a one-dimensional representation of floating points or 16 bits. One thing to consider is that the waveforms or like the data set um, for these models is not just like one waveform. So I'm working with one very specific thing to consider when working with generative AI systems is that we're working really much at high data set scales. So, for example, a small model, and these are still quite small models. I'm working with data sets of 3 hours of audio or 8 hours of audio, and in other projects, I'm working with like 20,000 hours of audio. So this is kind of the range, that within these sort of technologies, like this representation, right? It can represent like a very big quantity of audios, and hopefully it learns to generalize. It learns how to reconstruct these audios back into sound. So yeah, so this is kind of like the very technical background of like Semilla and what got me to that. So sidestepping a little bit. So I want to talk a little bit about the research context of Semilla. So in my work, as I was mentioning earlier, I'm very interested in mythology and in ancient histories. I think there was a question here. It is often mentioned that generative AI models cannot come up with new sound genres, but rather only just repeating what has come before. However, your explanation of the latent space implies that it actually can make new connections. Yes, that is my hypothesis, that through building these architectures, the way that you can then model them or the way that you can interact with them can actually produce new sounds. So that's a bit the hypothesis that I'm trying to experiment and work with to me, So going back a little bit to the research context of Semilla, so and in my work as exorcismos, so I'm very interested in the tensions between ancient technologies and specifically technologies for this project. I'm very interested in technologies of divination. I think this first idea was coming from this book that I was reading many years ago. It's called Atlas of Anomalous AI. I don't know if you can read it here, but yeah, Atlas of Anomalous AI. It's a very interesting anthology of essays and short stories. And in one of the stories and one of the essays, I couldn't find exactly which one is a pretty big one. They mention that AI technologies are essentially technology that is within the continuum of technologies of prediction. So technologies of prediction, meaning technologies like the tarot, like the I Ching. So technologies that try to make a prediction about the future in order to better control it. And also some would argue to it creates a contingency on the future, right? So by you making a prediction about the future, you can also realize that future, So by making that, it's like a bit between different understandings of divination, and different practices. So within this book, they talk about specifically the tarot in conjunction to generative AI systems. So these we're talking also very like even pre GPT-3. So already like most technologies, when you work with an AI network or with a generative AI system, the generative aspect, you also call it a prediction, right? So you're trying to predict what the future is essentially with these systems, right? In the case of sound, with certain models, such as auto-regressive models, you're literally, let's say that you have a waveform or that you're trying to predict a waveform. So you train it based on this data, and then you're essentially trying to predict what would be the next point in the samples of that waveform given the past. So you're predicting the future. So that's how you're generating sound. You're predicting the future in time through a certain representation of what is the possibilities of what can happen in the future based on what has been learned during the training process. So this is why it's a bit contested if AI systems can actually make a new prediction or create something new based on that they're only trained on past patterns, right? So the idea is that because you already know these patterns from the past, I think one way to frame artificial intelligence is that these are technologies that allow us to see patterns that were already there in the past, but there were no ways to make that link between those, or it was a bit more difficult to make that link between those two patterns. So there's a lot of discussion on more LLM based models, so ChatGPT based models, if they can make new discoveries by themselves, because people argue, and of course this is how they kind of work in practice, that they just kind of, they're what people call combinatorial creativity, right? So you have already a preset made of elements, and then you just combine them in different ways to create something new. And this can be seen as a form of creativity that is not necessarily mimicking. So they can exhibit that they can actually do, by going back to the idea of the latent space system. Let's say that you have a big enough model like large language model, and then you embed two different points of knowledge that of course maybe are in the system, but you're the one making that interlink between those 2 points. And that is something that I would argue is novelty, right? Because the system by itself requires an operator to do that connection, right? So that's something that uh, people are trying to do, to build autonomous systems that actually make those connections by themselves. But I'm more, with the Semilla project, I'm more talking about it as a music instrument where there is a ritual aspect to it. So there is a practice of divination. No? So going back to this part about the mythology, so within the mythology of specifically Mayan and Mexica mythology in what is now Mexico, there is a practice of, it's called divinación por medio del maíz, or divination through corn throwing or maize throwing. And essentially, this practice is, you can read about it even in the Popol Vuh, so the ancient Mayan sacred text, the original creation myth text, where in one scene, two of the gods are creating Earth, and the way that they create Earth is by throwing these corns, right? So they're predicting Earth into existence, right, by using this ritual of reading the patterns that emerge from the falling of the corn. So the argument that why would the gods use corn, or why would humans use corn in order to understand these systems, uh, would be that corn is, since it's part of nature, it has more access to patterns that are invisible to humans, or that are invisible to other beings, right? Because they are intrinsically made by nature, and they are growing, right? So they're seeds. So they have more access to these hidden patterns that they can then communicate to us. So that's kind of the argument that is that I researched from a paper. Let me see if I can share this paper. Yeah, here. So there's this paper by Araceli Rojas that is called Reading Maize, a Narrative and Psychological Approach to the Study of Divination in Mesoamerica. So this is a paper that talks specifically about this practice of corn reading. And within this, she frames it as the reading of maize, in her approach in this research, is approached here by employing the concepts of signs and symbols as described by Jung, and the notions of the chronotrope and dialogical narratives by Mikhail Bakhtin. So this idea of the chronotrope and dialogical narratives is basically similar to the tarot, in the sense that when you throw the corn and the shaman or you are reading the patterns from that corn, it's a personal narrative. So it's always in relation to your question, to your own life, how you interpret that pattern. So what I found is interesting about this paper is that she is more interested in that personal psychological narrative that you create for yourself by reading this random, or doing this ritual practice of throwing the corn, and giving a meaning to your question, or what is going to happen based on that. So it helps us create our own narratives in the subconscious, some would argue, but also into signs and symbols based on Jungian psychology. Of course, this is a more modern understanding of this, more clear understanding of this practice. But in the actual practice, so here you can see some of the background. No, so in pre-colonial times, the Nawa, so like the shamans, the Namakaski, and and diviners like Laolchiniani, and medicine men like the Tisitl used a special language during incantations and prayers, known as Nahueltocatl, also commonly named Nahualatol. This discourse, also employed in graphic form, is shown in the Borgia group. So this previous image that I showed you. This is from the Borgia Codex, and she describes it as a disguised language employed in religious texts, in religious context, as a bridge for communication with deities and ancestors. It makes use of diverse linguistic and rhetorical expressions such as parallelism, diaphragm, opposition, and redundancy to convey occult and mysterious meanings. This semantic universe of esoteric knowledge present in speech, images of codices, dreams, and presages is broad and open, full of metaphors, symbolic allusions, and archaic terminology. In particular, the nature of the oracular language, like the one found in the Borgia group or the Borgia Codex, the Maize reading, and even in other types of systems like tarot cards and the I Ching text and astrological chart, is also ambiguous and nebulous. So meaning that this interpretation, it's not, we can't think about this as a science, but rather as divination in itself, right? So it's already clouded in interpretation, but it does have some methodologies or ways of encoding and decoding the meanings. So when we talk about encoding and decoding, so this kind of research happened in parallel while I was building and working with generative neural networks for sound. I found this idea of the parallel of the random seeds. So going about in the code, I found myself that a lot of these systems need a seed, literally, quite literally, una semilla, where this seed is your entrance or your way to interact or to peer into the latent space of what the model has learned. So this, let me show you here more specifically. So this is one of the ways to read the corn. No? So once it's thrown into the mantle, there is a way to interpret that if the seed falls with the embryo upwards, it has a living or positive meaning, and if it has the opposite position, it has a negative meaning, right? So this is in relation to you. So basically, when you throw the corn, this is in relation to you, the person. So you yourself represent yourself as a seed, and you have this space, which is let's say, like a metaphor of the universe or the world or a city or whatever. So north, south, west, and east are represented here. And then from the different fallings of the corn, so for example, let's say here, so this is an interpretation of somebody who was asking about, I believe, their marriage, where these two people, so like the people asking about their marriage are these two seeds, and the falling of these seeds, so these are living seeds or positive seeds that are pointing towards these people, you can interpret that as abundance, wealth, children, family, and friends that bring support, right? So this is kind of like a good omen or a good reading based on that question, right? So the couple ends side by side, showing a harmonious arrangement, right? So this is like one interpretation of that reading, right? So there is a back and forth between the system of reading the corn or reading the seeds, where you ask the question and then you see the position of the other seeds in relation to yourself in order to make a story and make a prediction, right? So this is another scene. And here there's also like a negative note. So there can be also negative position based on different positions here. So this practice was very fascinating, that there is this idea of a predictive technology, such as the reading of the maize seeds with the act of predicting in machine learning. Again, going back to the first description, these are the economies, or these tensions between these two types of technologies that seemingly are very far apart in time and in space. They can form some kind of interrelationship in specifically for Semilla as a way to create an interface. So going to going here to the presentation again. So this is the instrument. So this instrument, Semilla, so is the actual physical instrument that was created in 2023 after some years doing research into generative neural networks for sound, where the idea of this instrument is that you have that prediction space here, and that would be your interface for seeding the latent space of the generative model through a computer vision or a webcam here on top that you can see here that reads the coordinates of each one of these seeds in order to create a random variable or a trajectory in the latent space of the model. So let me show you a quick video of some initial prototypes from Semilla. Any questions so far, comments?
I will say that Nadia and others are live sense making on the Miro board. So you can ask questions in chat, but you can also see like it's a burgeoning ecosystem of notes, screenshots, questions happening. So there might be a follow up in post. That also you might like to
Cool.
see,
Yeah.
Moises, is like collective sense. Actually, it's like exactly what you're talking about is collective sense making happening in real time. But sharing too many screens, I think, would be chaotic right now. This is great.
Yeah, cool. So this is one of I want to show you one of the initial prototypes of Semilla. So this is for the live instrument. So here on the background, you can see a Maximus P patch that was used for the initial prototype. And within that patch, if you don't know about Maximus P, but you can just know that one of the generative models that has been trained on percussion instruments is being fed the position of the seeds as parameters into this latent space. So you can think about them just as knobs, no? So these trajectories are knobs within the dimensions of the model. Oop, I think so a bit the idea here on this first prototype is to use so just like a bit of I don't know if the video was people could see it so well. For me, it was a bit stopping, but I can share here maybe the link so everybody can see it at home. So the idea was that to map these coordinates of the seeds and use the actual practice of the prediction with the seeds as the interface with the instrument, right? Yeah, so essentially the instrument itself, right now there is this hardware, so it's the instrument itself that the way to kind of understand the playability or the, let's say, the musicality or the interface with the instrument is that since we're working or we're kind of generating sound based on these, again, going back to the latent representation node, so this encased representation, this hidden representation of the model for sound, the idea is that if you create random and very specific trajectories within using the seeds within this latent space, you can potentially get, in this case, new sounds that are not, in this case, very specifically, rhythms that are not really existing in the latent space of the model. No? So it's a percussion model trained on very specific rhythms, and a lot of these rhythms that are emerging from this transversal of the latent space through the throwing of the seeds is completely new because it's more guided by the dynamics of how these seeds get updated in real time through the computer vision system, and then this in itself drives you to understanding how the latent space itself is constructed, right? So, for example, when I'm performing with Semilla, I'm doing a throw, and depending on the clusters that I read of how the corn fell in this space, I can do that relationship with the actual output sound, and then I can start understanding this black box of these representations just based on this iterative process of throwing of the seeds as a performance gesture. So there is a bit about exploring autonomy in machine learning enabled instruments where the difference between let's say a normal synthesizer that it doesn't have machine learning is that the synthesizer itself, you go with it with the idea that you have parameters, that you know what each parameter is doing, like pitch or frequency or whatever other parameter, and then you control it. No, you kind of guide it in different places. With Semilla, you actually don't know where are these, like there are certain parameters, but you are still uncovering through this throwing of the seeds, how these parameters are mapped autonomously by the machine learning model. So this instrument itself requires a lot of listening to the instrument itself rather than just a sort of performance chip for to actually play it. No? So you need to start uncovering the patterns so that if your seeds are in certain regions of this space, you have certain sounds, but not all the time, right? It still has a non-deterministic nature based on the model itself that you don't know exactly in which direction it's going to be. So this was the first, let's say, phase of Semilla to try to understand this idea of how to engage with divination methods and to engage essentially with randomness as a compositional and as a device or technique to explore the underlying nature of machine learning models for generative sound synthesis. And of course, because I don't think any instrument would be kind of complete without other people using it. So this kind of led me to the next project that I would like to talk about, which is a mutualismo
One
that was
question before
released
we move to the
in.
next project. One question from Jaco or Yako. I think it's showing on the screen. What is the main function of Max MSP in your process? Is this where your main instrument mainly exists during a performance context or also outside the environment for development?
So more specific on Max MSP. So Max was only used for the prototyping of the hardware instrument, but actually it's running embedded pure data, which is like an open source version of Max MSP in a Raspberry Pi right now. So this instrument is all embedded. It's not a controller, let's say, that I connect to my laptop and then I perform with the laptop itself. It's actually the instrument itself is generating everything.
Thank you.
So I was very interested in this idea of the provenance of the data, right? So I talked about this idea of like non-mimicry of data sets, right? And specifically non-mimicry of artists, like because we as artists are the ones engaging with, or right now a lot has changed since the beginning of Semilla. So right now you actually have big tech companies such as Suno or others that are actually making these one-click full compositional AI slop music or whatever you want to call it. And this is a very different approach. It's like a very different approach to this type of modeling because in the case of products like those, I would argue that Semilla itself is first of all, it's not trying to emulate a song. It's not trying to emulate a composition. It's an instrument to produce music, no, to create compositions. You have to engage with the system. You can't just like click a button with Semilla. I mean, you can throw the corn and then just kind of keep listening what comes out of it. But the idea is not it's not that, no. Like the idea is to engage with the instrument constantly and perform with it, right? To create new music with it. It's not a fully autonomous generative AI system. So that's the big difference that I want to make between Semilla um, and other systems that are like more recent for that. Basically, the whole narrative right now with AI music, I feel, or most of the narrative is centered on these systems like Suno and big AI systems, specifically because those are the ones that are posing more threats to the livelihoods of musicians, to the music industry, essentially, or like streaming, especially, and content creation. You know, so this is a totally different approach to engaging with these type of systems, even though you can probably find a VAE or like one of these architectures inside one of these two node systems in a way, right? But it's totally different approach of how I use and engage with the technology. So going back to this approach of like, what would it be? So I was very interested in, okay, now we have this representation of very small models that can run in real time. What would be the emergent music of having a lot of these models that are actually curated by different artists, not only myself, with their own data, right? So that was a very important point. Like, what does it mean to kind of embed or to kind of become a sonic network through the curation of a small data approach, um, generative neural networks. So the idea of this project was to invite 12 other musicians to curate a data set of what they would like the AI to learn. So basically a representation of their own musical styles and music compositions in order to create this sort of AI mutual or this kind of externalized version of themselves through the neural networks, which they could engage with using the Semilla interface, right? So for this project, there is a software version of Semilla, which you can see here, I think, on the screen. So this is the actual software that the musicians were performing with. And yeah, so for example, each one of the artists in this collaboration had access to there. So for example, this is one of the artists that collaborated in this project, El Real 21, a musician from Mexico, mostly producer. And this musician worked with Semilla, not only with their own model, but also with the whole collectivity's model. So the idea of this album was to have each artist have access to all the our collective. So 13 models. So each artist had access to everybody's models, right? So within this process, there was a lot of conversations like about the data sets that they wanted to curate, of course, but also about the sharing of the models. So everybody was like totally fine with everybody sharing their own models among themselves for this project. And basically there was not really a lot of like constraints on that. The only constraint within the music making process was that they use Semilla in some way for creating this album, right? Each artist collaborated with one track for the album, and that was the only constraint. So I'm going to share with you the first. So we worked also with a collective from Chile. So I'm going to share it maybe here in the chat, and maybe if people want to watch it. So because I think the video wasn't streaming so well. So this was the first music video that was made by HyperAcon Collective, so a visual collective in Chile using generative AI. And this is a track that was contributed by Clochi Lee in collaboration with Semilla that she produced most of the track using her own model, and I think she also used other musicians' models. So that is a bit of the premise, and you can find the album here if you want to check it out. So yeah, so that's maybe we can stop it here. So that was the first single from the album from Chili of the composition and with the visuals from Hypericon Collective in Chile. And yeah, so for the visuals, I mean, the artists were more interested in exploring like what they call the mythopoetics of minerals, especially in regards to minerals being the backbone of also machine learning at the moment, no? So for GPUs and computation. So they wanted to explore more texture-based explorations into these representations within certain visual models. Uh, And also to do this kind of recursive thing where minerals themselves are the ones that are kind of powering or making computers and GPUs work. So it's a bit of this kind of exploring them through the AI materiality of something very, very tangible. And yeah, going back to the album. So this was, you can listen to the album here on this. I think I shared the link on the chat. No, so I wanted to talk about a little bit about the impressions of the artists from Mutualismo. So some of the artists' impressions from working with this type of models, so like their own Semilla or Semilla AI model, is that some of them described it as uncanny because they were listening to kind of like a spectre of themselves, they call it. No? So they were making music with this externalized spirit, they call it, that was putting out stuff that they kind of remembered, but because a lot of these networks were a little bit underfitted, right? So we're trying not to completely replicate. It was more like remnants and small parts of their own music, but totally enmeshed in other types of sounds that they themselves hadn't put together, but they could recognize from memories, like, ah, wow, this is kind of some sounds from this composition that I did some years ago, or this is something that happened, like these types of sounds or something that I produced more recently, but not in a verbatim way. It wasn't ever that, oh, this sample is coming from this song. It was more like something that kind of morphing around the creation process. So each track is very different because each musician were basically using their own style of music making, incorporating other tools alongside Semilla. So the interesting part was that some of the musicians actually tried. So I think Hayam Alami's piece, so track number 7, is actually using all the different models from all the different musicians that participated in the album for that track. So some artists took this approach, some other artists just used their own model or a couple of different models, and then they kind of sampled. For example, the track with that I did with Eli Real 21, he's mostly a producer, so he was mostly sampling stuff from the tool. And then my collaboration was that he would send me parts that he composed, and then I would pass them through my own model and improvise with that in real time using the instrument. So that was a little bit of the process, and um, yeah, I guess we can start taking some questions, or I don't know. I think that's it from me.
Maybe I could. Oh, nice. Yeah, thank you so much. Yeah, I'm really curious about this like, collaboration process with the other musicians. Like, how familiar were they with AI tools? Like, had they already used some before, or did you have to go through like an onboarding kind of thing? Yeah, what was the learning curve like for them?
Yeah, so this project happened in 2022. That's where the actual composition happened. So there wasn't much around. I think ChatGPT wasn't even released yet. So like the engagement. I mean, some of the artists are also working in technology. So some of the other artists are actually working with machine learning themselves. So they had a better understanding of like the workflow. But there was a bit of an onboarding happening, but it was more casual in a way. It wasn't like a tech startup kind of vibe, like let me get you onboarded to the instrument. It was more like we were having a session, like I was kind of like playing with the instrument. I was kind of explaining the different interface components, like this is what you can do, this is how you change model, and so on and so forth. But it's a very intuitive interface. I think it's more like exploratory interface. So I think the exchanges that happened a bit before had to do more with the type of how the technology is working. itself. So more like about like what is this actually doing? You know, like what is this actually? What are these parameters that I'm moving? Like what are they actually doing? You know, so, and I always refer to them back to the idea of the latent space of how they could find regions. You know? Yeah. So basically, the interface is very intuitive. I'm gonna share it. So essentially, it's XY pads, right? So you can kind of tell that whenever you move the seeds into different directions, you might get different stuff. And then from this interaction, of course, you can map it to your own. I'm trying to share the patch, but anyways. But yeah, I mean, I'll share with everybody the link for Semilla. I mean, if they want to try it out, it's actually a donation-based project, so you can actually download it for free as well. You need max MSP to install it, but there is the instructions on the site. So the onboarding was quite casual in that way. Going back to your question, yeah.
Yeah, that's great. I think it's best when, you do and you learn at the same time. So, for sure. And I'm also wondering, what would you say is like an important thing for musicians to know if they're interested in training maybe their own model? And did like the musicians that you worked with, did they show any interest like after this project to making their own model maybe from scratch?
I think some of them, but I think there were quite a few that actually kept working with other models and were more interested. But I think, yeah, I think to be quite honest, this was quite early still. There's a version 2 coming up of Semilla, hopefully this year at some point, that is improving a lot of like the architectural things. So one of the limitations of these type of working with generative AI is the hardware constraints. I mean, this model that we're using can work with a CPU, so it's actually doesn't need such heavy computational requirements. But still, it's a bit of a project that was a bit experimental. So Rave itself was somebody's PhD. So the main author, Antoine Cayon's PhD project. So like the support for the project has kind of, now it's managed by IRCAM in Paris, but it's kind of iffy. I don't know. The project is a bit, it's still there, but I don't know. It's more community, like most open source projects, like community supported, project. It's not like a company behind it. It's more IRCAM, but yeah, they have a lot of stuff, I guess.
Question on, so, you mentioned that for the album, each of your collaborators like trained up their own model. Can you tell us more about or personalize the model or like put inputs in? Can you tell us more about what that process was actually like?
Yeah,
How much of their stuff was put in, and then these details.
yeah. So it was mostly so each artist. I mean, I trained everybody's models. I trained all the different artist models. But the process looked like this. So there was like an invitation, like a formal invitation to the project, where I described a bit the concept behind it, and then there was like a bit of yeah, like asking each one of the artists to contribute at least a couple of hours of their own material, and to really think like what kind of style they wanted to embed into the network. So most of the artists chose their own music, so their own finished music, and they essentially gave me these files, and then I trained each one of the models on these data sets. So there was a couple of artists actually who were actually more proficient in machine learning. They worked with machine learning before. They actually opted to do, for example, they wanted to explore their vocals. So they only sent me their vocal samples, no? So they extracted all their vocal material from their songs and they wanted to explore that. Or another one sent me only like rhythmical material, so like percussion, more like this type of data set. And other artists send me like the whole tracks, like full compositions, especially like Kamaru, who's like an ambient musician, ambient music. He sent me his whole compositions. So it's a bit diverse of like the approaches, that each artist took. But yeah, it was, I think the better sounding models, obviously, because we're working with very small models in like I think not even 100 million parameters, so they're quite small. Of course, they have a limitation of like the sound quality that they can have. So this is why the album sounds so cohesive, because the model itself, or like not even the model itself, but the architecture itself has a specific sound. So it has this kind of weird morphing sound that is already present, regardless of what you train it in. You know, it just kind of morphs, so it has its own sound quality, like a synthesizer.
So there's like a textural element or like another collaborator, which is the model itself, that like lent
Exactly.
like bits of itself into the thing. And I can see in like the merch link, the download link for Semilla AI, that includes 5 models, which is really cool. So these are the models that you're talking about that were trained on. Do you have a README file about each of these? You also don't have to make one if you don't have one. Like for each of these models, like with some of these details that you mentioned, right? Where it's like some included vocals only or rhythm. Like, do each of these models have a model card?
We didn't have model cards back then, but yeah, they should. Yeah, I can talk about them. So there's 5 models included in the download. So the first model is from my own music, actually. So it's actually a synthetic data model. So it's actually trained on jukebox generated tracks from an album that I did in 2021 called Okachiwali. So it was trained on the output of another AI model. So it's a synthetic data set model, this first one. Um, and then the Salterio model is based on a public domain. So Salterio is a instrument. I mean, it's like the Psalter, so it's in many different regions of the world. But in Mexico, there was this instrument that is sort of like a lap harp, you can call it. It's like this, you play it with these mallets. And I trained it on open source data from this. So it's like from early 1900s material to kind of capture the sound quality of this. So it was like all open source, um, public domain sounds to train this. And then the Kumbus was the Kumbus Saz. So it's like yeah, there's this instrument called Kumbus Saz in Turkey, but in many places of that region. That was recorded with a friend, a colleague of mine that plays this instrument, and we recorded the data sets. He recorded like 2 hours or something like this, and then he was like, "Yeah, you can release it, of course." And then this liquid model, if I remember correctly, is coming from like open source data set of like liquid drum and bass and jungle loops, like from archive. So like old school drum and bass samples, like public domain, and trained on about 8 hours of that. So the Okachiwali is trained on about 5 hours. Salterio also like 8 hours. Kumbus was 2 hours, so it's quite small model. This liquid one was also quite a few hours, 8 hours or something like this. And then this Darbuka model is one of the ones that had come pre-trained from IDCAM Wraith. So I think it was, I'm not sure what they trained it on, but it's one of these public available models.
Cool. And like when you're talking about like the source material for these models, one synthetic data, interesting. Another, you made the data set yourself, and then you have like public domain, free access stuff. Is this like back in the day cafe? The conversation was really early about getting the appropriate consents for this stuff. Did you have an intuition that you should? What was your reasoning for getting the data in the ways that you got it? Because this is so different to like how folks talk about this data being collected from like big tech stuff, right? But you're talking about pre-ChatGPT days, before this was like a big conversation. So what was your decision-making process on how you got this data in these ways?
No, I mean, I think this conversation now is is kind of mainstream. Like it's now an ubiquitous conversation about, especially regarding AI. But I was thinking about, so there's an album that I did. So if you go to my music albums, there's an album that I did in 2021 where the idea was to use publicly available data. So it's based on an archive of music from a YouTube channel that's been archiving this music. And the interesting part about this music is that it's mostly been shared online freely. And of course, there wasn't this conversation because it includes the music of a lot of producers. Within this, of course,
Yeah.
there wasn't this conversation to ask every musician for permission to use their data for the model. But I think in the way that I wanted to do it is that because this information or this style of music, the tribal guarachero music, has been always like an MP3 exchange kind of music between producers. So the decision to make the model itself that was trained on this music also open source was something that was kind of, it just made sense to do. Like it wouldn't feel right for me to like make an album from this style of music and then sell the model. No, like it just didn't make any sense because first of all, the my engagement with this kind of music has been always like file sharing wise. So I would like it to also be to stay like that, even if the provenance of the music is now coming from a model. I would like this music to also be public domain kind of.
That's such an interesting point, and something that Nitya and I have talked about a bunch, but about this like lineage of how music has always been made, right? So you're talking about file sharing. Like, we've talked about sampling and how like lessons learned from not new ways of making music. It makes sense that that logic is applied to new tools or instruments that we're making, like this one. And so it's interesting to hear you talk about like uh, the catalyst of this philosophy, the philosophies behind like this being open source and like how you train these things comes from your like like your intuition as a music maker, because this is like a habit that's already been seeded with you.
No, no, totally. I mean, yeah, if I mean, I worked a lot with in my previous music project. We worked a lot with in my I had a band for like 6, 7 years, and we worked a lot with sampling a lot. So definitely I had this precedent, right? That we worked with sampling and I mean, the way we worked with sampling or well producing was to it was kind of like pre-machine learning way, but in order to make something that now is made by machine learning. So we were processing the samples a lot, like a lot, till we got to these sounds that were obviously provenance from the original samples, but they had been flipped so much that it was only kind of like the essence of the original sound in a way. So it was already kind of there. And in this actually this way of working before was one of the reasons that I got into machine learning, especially for generative sound synthesis, because it was a very similar approach, right? You get these sounds that are not the sound itself, but the essence or the representation, sort of that data set that you're trying to analyze.
Yeah, and it also sounds like the origins of your exploration being not rooted in imitation, but of like getting down
Exactly.
to some element that is glitched, not beyond recognition, but is like an homage to the original
Yeah,
permutations, blah,
for
blah,
sure.
blah, to this new thing. Um, yeah, and I, for me, it's really helpful to hear how this like experience that you have of making music pre AI. Not that I want to make an arbitrary like chapter end or beginning for this, but like your work pre AI, you can totally see how it just fluidly goes into your work with AI. There is no like separation of like principle or value, or even like goal and output of what you want sound to come out afterwards. Um, so it's nice to hear this like fluidity across what feels like before, well, specifically for this project, before Semilla and after Semilla. Um, I have maybe a stupid question. If Semilla is downloadable, right? Does it mean that it's running off of like the compute power of your own computer?
Exactly. So that's a bit the idea when working with this specific architecture, that it's working very much like it works pretty good with low power computers or just like normal consumer laptops. You can even run it on a Raspberry Pi, which is not super powerful computationally, but it still works on there. So it's quite a flexible algorithm, or yeah, machine learning algorithm that doesn't require GPU data centers or anything like that.
And then was that a decision that was made? Why was that decision made? Because I'm also thinking about like, the ongoing cost of like having this be browser available in the cloud, which would be like a cost to you or whoever's hosting it.
Of course.
What was the decision made about this? Was it like a decentralized thing? Like everyone, this is like a file sharing, comes from the lineage of file sharing? Or was this like a cost thought? Was there any thought? What was thought?
I mean, yeah, I mean, first of all, it felt like the first time because as I mentioned before, like I had been working on the Semilla project for some years already before this release. And just the way that I was working it back then, just it required you to have a server and to have GPU power to generate and so on. So this algorithm, this um, Rave algorithm, because it's designed for real-time use, it really changed the methodology. So, I mean, personally, it just makes sense to have musicians have something on their laptop like as they would any other electronic instruments, like software instruments. So it was more like also an intuition thing. Like, well, I'm not gonna go into managing a server and GPU clusters and stuff like that. Even though a lot of the newer generative AI stuff, because of the scale, and I'm not saying they don't produce, very impressive results, or, they're more high quality, of course, because there are limitations in running local models on the kind of outputs that you would get. But I think there was a good trade-off. I prefer to be a bit more lo-fi, but still have full control over the models and make like interesting workflows without having to depend on a cloud service than just like having that other approach. And also at the moment, like text to music models were not really a thing. Like, these didn't really exist at the point. It was just like generative models without conditioning.
That makes a lot of sense. We are over the pre-scheduled time, even though we knew it was going to go over anyways. I think maybe a 2-hour segment is actually what we need to allot for these types of conversations, because it's a lot to cover in like the project, the artistic concept of the project, the philosophies behind it, process, also a bit of show and tell. It's a lot to cover in 90. So thanks for everyone for sticking around, and thanks for folks who are listening after the fact for the long conversation. I think this is like a, a good reason to have long conversations. Any final questions before we close up? This is your chance to say it. I'm just going to look through chat. To which extent do you feel you require transparency with the technology to be able to use it as an instrument? And to which extent do you want to be surprised by the outcome by not knowing what will happen? Those are 2 questions.
Yeah, I mean, generative neural networks are itself not very transparent technology, like by design. I mean, we can know the inner workings and the math and stuff like that, but like the training process or like the actual production of the weights or like the trained model is not really a transparent process because it happens autonomously through the training process. So this is the part that I find interesting as well, that I'm curious about these representations or misrepresentations that can happen from that actual training process of the technology. So I am interested in the transparency and like understanding the underlying mechanisms of generative AI technologies, and this is what kind of drove me into these technologies, because I didn't really understand exactly how they worked, which led me to learn about them. So from my side, there is like a desire to know and to make these technologies a bit more transparent. At the same time, there is this inherent opacity that is interesting because it's kind of like a chance-based method within the process. So I think, yeah, like I'm not, because I mean, I come from composition, and some years ago, like around 7 years ago, from being like an electronic music producer, timeline-based producer, I shifted my musical practice to more improvisational type of music. So like live music making with instruments, synthesizers, and so on, that I'm more drawn now to chance-based or non-deterministic ways of making music. It's not that I don't know what the sound is going to be like completely. It's not going to be like, oh, I train it on, I don't know, like drum machines and suddenly it sounds like a dog or something like that. Like, or maybe it can happen, but it's rare that that happens. But there is a way that you can go out of the distribution, like out of distribution drum machine model that is interesting to me, like this liminal phase between the representation of the like original training set and this noise and chaos. Like there's this region of playfulness that you can engage with these instruments. So that's the part that I'm interested in.
Thanks, man. Nitya, do you have any questions?
No, I don't think I have any more questions, but I think it's super interesting to see how your approach to just music making in general really influenced naturally your way of making this tool and this model. And yeah, it's kind of like the process of music making. Like, it's not, you never know what you might result with or what the result is going to be. So, yeah, thank you so much. Yeah.
Thank you.
Yeah, thanks, Moises, for being a smart person, for sharing with us. Thank you to everyone in chat for joining. I know that there's some folks joining from America, which is like a crazy way to start your day, is to like have a coffee and have this chat. We're going to also like process this conversation on the Miro. Also, you'll find it in the report. So you can send follow-ups to however you found out, like, the RSVP, but you can reply to the Luma link or the Luma email that you've gotten. And yeah, thanks for going through the archives to bring us through your maker process from what feels like 100 years ago. We appreciate the effort.
Thank you, everybody.
Yeah, thank you.